Hello dear students, welcome to today's session. In this session, let us understand the modern periodic table, introduction to periods and groups. Before that, let us recall the modern periodic law. What does the modern periodic law states? The modern periodic law states that the properties of the elements are the periodic functions of their atomic number. Here, the atomic number is given the more importance. All the elements in the modern periodic table, they are arranged in the increasing order of their atomic number. Correct? And in the modern periodic table, it has 18 vertical columns, which are known as groups, and 7 horizontal rows, which are known as periods. If you look at this table, you can find out the groups. There are totally how many groups? There are totally 18 groups and there are 7 periods. Correct? So now, let us understand the modern periodic table in detail. Let us understand the periods and groups in detail. Okay, so as I told you, what is meant by periods? The periods are the horizontal rows present in the periodic table, right? These are the horizontal rows. So all these horizontal rows are called as periods in the periodic table. And these periods have some properties. That every period has the consecutive atomic numbers. I repeat, every period has the consecutive atomic number. For example, if you look at this table, the elements in this table, for example, you look at this table, the elements in this table are arranged in order. For example, you can see it is 11, 12, 13, 14, 15, 16, 17, 18, correct? The elements have the consecutive atomic number. They are arranged in the order. And also, the number of elements in the period is fixed by the maximum number of electrons which can be accommodated in the valence shell of an atom. That means, if you look at this period, you can see the first period is having 2 elements, correct? And if you look at the second period, it is having 8 elements, and followed by third period, it is also having the 8 elements, correct? So I told you that the elements in this period, they are fixed by the maximum number of electrons. If you look at the first period, the helium is having maximum 2 electrons. The 2 electrons are fixed on its shell. And if you look at the neon, what is the atomic number of neon? 10, correct? And its electronic configuration is 2,8. And as I told you, how many? 8. Correct. So 8 electrons are fixed on its outermost shell of the element. And if you look at the argon, it is 18th element, correct? And if it is 18th element, its electronic configuration will be 2,8,8. Correct. Totally it is 18. And here also the maximum number of electrons in the period, they are fixed. Correct? Hence, we have maximum 2 elements in the first period, and in the second period, we have 8 elements. In the third period also, we have 8 elements. In the fourth period, we have 18 elements. Fifth period also, we have 18 elements. Followed by the sixth period, we have 32 elements. When are 32 elements, you might have a confusion. If you look at this fifth and sixth period, they're all looking similar. How come 32 elements? Some of the elements are placed here. Okay? So this is how it has been judged. That is, the maximum number of electrons are fixed in each period. Correct? And all the elements in the period, they contain same number of shells. I repeat, all the elements in the period, they contain same number of shells. Let me give an example to understand. If you look at this period, second period, the first element is lithium, correct? And its electronic configuration is 2,1. Correct? And then if you look at beryllium, it is 2,2. Correct? And if you look at boron, it is also second period. If you look at boron, it is 2,3. If you look at carbon, it is 2,4. Like that, right? If you look at all these 4 elements, they're all having same number of shells. See, 1, 2. 2 shells. Here also beryllium 1, 2. Boron 1, 2. Then carbon 1, 2. Correct? So all the elements which are present in the same period, they'll be having same number of shells. Clear? And the maximum number of electrons that can be accommodated in a shell, it depends upon the formula 2n square. I hope you all are very familiar with this 2n square formula, where n is the number of shells. Correct? So if I want to know how many electrons that can be accommodated in the boron, I should just follow this formula. By knowing this formula, I can come to know how many maximum number of electrons can be accommodated in this shell. Correct? I repeat, the maximum number of electrons that can be accommodated in a shell, that depends on the formula called 2n square. And it is the valence electron which decides which element will be first and which element will be last. What is valence electron? I told you, valence electron is the number of electron which is found on the outermost shell. Correct. So as I told you now, it decides. Who decides? The valence electron decides which element has to come first and which element has to be next. Let us see how it is. So if you look at the sodium, its electronic configuration is 2, 8, 1, right, because it is 11, and followed by magnesium, it is 2, 8, 2. Correct. Now if you add this totally, you get how much? 12. And if you add this, you will get 11. Now just tell me which has to come first and which has to become next. If you look at this, you can easily identify that number 11 has to be arranged first and 12 has to be arranged after 11. Correct. So this is how we decide. That is, the periodic table decides that which element has to come first and which element has to come next. So it is all that valence electrons, the number of valence electrons, they decides. Okay. If you look at this, it is having only one valence electron. It is having two valence electron, right? So the element which is having one valence electron will come first, and the element which is having two valence electron will come next. Followed by, if the element aluminium, it is having the valence electron 2, 8, 3, then it is having 3 valence electron. So magnesium is having 2, 8, 2, right? It is having 2 valence electron. So 2 has to come first, and then 3, followed by 2. Correct? So this is how the valence electron decide which element has to come first and which has to become next. Okay, and if you look at the first period, it has only 2 elements. You can see the first period, it is having only 2 elements, right? It is hydrogen and helium, and hence it is called as a short period. I just want to recall once again whatever I have told you before moving to the next concept. So I told you that the horizontal rows in the periodic table, it is called as the periods, correct? And we also discussed that elements in the periods have consecutive atomic number. That is, if it is 1, then it has to be 2, then it has to be 3, then it has to be 4, like that. It has to be arranged in order. And the number of elements in the period, are fixed by the maximum number of electrons which can be accommodated in the various shell. I told you, right? In the first period, we have maximum 2 electrons. So the number of elements in the first period is 2. And in the next period, we have totally 8 elements. And the 8th element is accommodated by 8 electrons on its outermost shell. Correct? And followed by the third period is also having 8 elements. And the last element in the third period, which is the last element in the third period, look at here. It is the argon, right? It is 18. Then it is 2, 8, 8. It is also accommodated by 8 electron on its outermost shell. Correct? So that is how we decide. That is, the elements in the period is fixed by the maximum number of electrons which can be accommodated in the various shells of an atom. This we have discussed. Next, all the elements in a group contain same number of shells. That also I have showed you how it is. If it is in a second period, the lithium, I told you, right? If it is 2, 1, then the next element is 2, 2, then next element is 2, 3, right? So all these elements in the period, they have a same number of shells. 2 shells, 2 shells, 2 shells. Correct? And we also discussed that maximum number of electrons that can be accommodated in a shell, it depends upon the formula 2n square. Correct? And I also told you, it is that the valence electron decides that which element has to come first and which element has to be next. That also I have told you that if the element is having the valence electron 2 comma 1, then this 1 has to be arranged first. Then if it is 2 comma 2, then after this has to be arranged, right? It is a valence electron which decides that which element has to be arranged first and which has to be next. If you look at here also, you can see this is sodium and magnesium. Sodium is having 2 comma 8 comma 1, correct? And magnesium 2 comma 8 comma 2, correct? So sodium has to be arranged first and followed by the magnesium, because the valence electron of sodium is 1 and followed by the magnesium is 2. So now if you look at the modern periodic table, the first period contains 2 elements. The first period contains 2 elements. If you look at this table, you can see the first period contains 2 elements, right? So hence, this period is called as a very short period. It is called as a very short period. And second period contains 8 elements. It is called as short period. Third period contains 8 elements. It is called as short period. Fourth period, 18 elements and long period. It is called as long period. Fifth period, it contains 18 elements. It is also called as long period. And sixth period, it is containing 32 elements. It is called as very long period. If you look at this table, you will be able to clearly understand 2 elements, very short period, long period, and this is 32 elements. I told you some of the elements are kept here. So it is a very long period. Clear? So now let us understand in detail about groups. Till now we have understood about the periods, correct? So here are some groups. So what are groups? The groups are the vertical columns present in the periodic table, correct? The vertical columns present in the periodic table, they are called as groups. And these groups, they are called as groups because I told you they have the similar chemical properties. And if you look at the groups, they do not have the consecutive atomic number. So when I was telling about a period, I told the consecutive atomic number maybe like after element 3, there will be element 4, 5 like that, right? It is when I talk about a period. When I talk about group, you can see, let us suppose this is the first group, okay? So hydrogen is the first group, right? So in the first group, the atomic number of hydrogen is 1, right? Followed by lithium, it is 3. And potassium, it is 11. And this is sodium. Sodium, it is 11. Potassium, it is 19. Correct? So here, if you look at their atomic numbers, they are not consecutive. They are not in order. Correct? And elements in a group, they have same number of valence electrons. I repeat, elements in the group, they have same number of valence electrons. See, if you look at, I'll give another group example, okay? If you look at this group, okay? So it is beryllium, right? Beryllium, atomic number 4, and its electronic configuration is 2, 2. And magnesium, it is 12, and then it is 2, 8, 2, and then calcium 20, it is 2, 8, 8, 2. Correct? So if you look at each and every element in the group, they have the same number of valence electrons in its outermost shell, 2, 2, 2. Correct? So once again I repeat, all the elements in the group, they have same number of valence electron. If you look at this, you will get an idea. You can also sit and work out for this also. So hydrogen 1, lithium 2, 1, sodium 2, 8, 1. Correct? So you can see 1, 1, 1. All the elements in this group are having same number of valence electrons. Correct? So next, All the elements in the group have the similar electronic configuration. I repeat, all the elements in the group, they have the similar electronic configuration. As I showed you now, it is 2 comma, sorry, hydrogen it is 1, correct? Hydrogen it is 1 and followed by lithium 2 comma 1 and so on. So next, the elements in the group show similar chemical and physical properties. I repeat, the elements which are present in the group, they show similar chemical and physical properties. And one more thing you want to know here is, when I talk about group, for example, this group, this is the 18th group, right? So when I talk about it, the valence electron, helium, except helium in this group, all the other elements which are present have 8 electrons on in its outermost shell. Helium is having only 2 electrons, right? Neon, it is having valence atomic number 10, it is 2,8. Then argon 2,8,8, correct? So all the other elements are having 8 except helium. Okay, and all the elements in the group, as I told you, they have a similar electronic configuration and they show similar chemical and physical properties also. And one more important thing which you have to understand here is the number of shells, they keep on increasing as we go down the group. I repeat, the number of shells keep on increasing as we go down the group. For example, helium. Helium is having 2 electrons. So it can accommodate only one shell, right? Neon. So it is having 2 atomic number 10. So its ECs, that is electronic configuration, is 2,8. Then followed by argon 2,8,8. If you look at this, the elements in the group, the elements, this is helium, neon, argon. The elements in the group, they keep on increasing their shell. As we go down the group, the number of shells increases. See, here there is only one shell. Here there are 2 shells. Here there is 3 shells. Correct? So this is how the elements which are present in the group, if we go down the group, the number of shells keep on increases. Correct? Now, let us understand the position of hydrogen in the periodic table. When I look at the hydrogen is placed on the top of the group. That is in the first place because the electronic configuration of the hydrogen is similar to that of alkali metals. I told hydrogen can perform both as well as alkali metals and the halogen metals. I told you in my previous slide only. But the properties of hydrogen is not similar to the alkali metals, not completely similar to the alkali metals, because the size of the hydrogen is very small. If we think these are all alkali metals, okay, the property of the hydrogen is not completely similar to the alkali because the size of the hydrogen is small in the periodic table. Correct? Next, now let us understand the position of metals and non-metals in the periodic table. If you look at the periodic table, starting from this region, so hydrogen is a non-metal, okay, starting from this region till here, okay, they all are metals. These are all metals. So the elements which are present on the left hand side of the periodic table, they are all metals. There are so many metals compared to non-metals. The elements which are present in the periodic table, they are all metals. Okay, starting from this lithium till here, as I told you, these are all metals. So you can see the green color thing here. So these are all metalloids. Why it is called the green color thing? Okay, these are all called metalloids because they perform the property of both metal as well as non-metal. Hence they are called metalloids, but still it is debatable. And where are the non-metals? These are all these are non-metals. The right hand side, the elements which are present on the right hand side of the periodic table, they're all non-metals. Correct? And please remember, in this class we will be covering only certain groups. That is group 1. We will be covering group 1, group 2, group 13, 14, 15, 16, 17 as well as 18. Only these we will be covering because groups which are present in the middle, they are little complex, and you'll be studying those groups in your higher classes. Okay, so as I told you, the groups which we are covering in this class, that is 1, 2 and 13, from 13 to 18. The group 1 elements have one valence electron. I repeat, the group 1 elements have one valence electron. Suppose the group 1 element, which are the elements of group 1? If you look at this table, you will understand group 1 elements are hydrogen and helium, correct? It is having one valence electron. Hydrogen 1 on in its outer shell, helium 2, 1, correct? So the group 1 elements have only one valence electron on its outermost shell. And group 2 elements, they have two valence electrons. Group 3 elements, they have three valence electrons. Group 4, group 13, 3 valence electron. Group 14, 4 valence electron. Group 15, 5 valence electron. Group 16, 6 valence electron. And group 17, 7 valence electron. So this is how the valence electrons are decided. So we are going to study the property of these elements in this class. So in my next slide, I will be helping out to understand clearly about the trends of the periodic table. That is, we are going to understand about the trends in modern periodic table. We will be understanding the valence electrons, atomic number, valency, size of the atoms, all those things we will understand. In my next slide, I'll teach you. So until, take care.